Hi everyone, Assalamualaikum warahmatullahi wabarakatuh. Welcome to subject CHM421, which is Analytical Chemistry. This video will cover the introduction of Analytical Chemistry. For this subject, it involved the theories and techniques in analytical chemistry. Student will define concepts, explain principle and application, solve qualitative and quantitative problems, perform experiments in laboratory. The student also will be assessed through paper examination, tests and quizzes, laboratory skills, and also laboratory reports. The course learning outcomes. At the end of the course, students should be able to describe the function of laboratory apparatus, standard laboratory techniques, as well as the principle involved in sampling and preparing laboratory samples. Explain the principle and application of volumetric, gravimetric, and basic chromatography analysis to solve the reliability of experimental data. Students will demonstrate the theories covered by performing experiments on volumetric titration, gravimetric analysis, and chromatography. The student also should be able to write a report on experimental findings in a scientific manner. What is analytical chemistry? It is a branch of chemistry that deals with the analysis of substance. Substance, sometimes we call it analyte, that present in the sample. The analysis can be done qualitatively or quantitatively. Therefore, the analytical chemistry involves separation, identification, and determination of interested analyte in the sample. You can watch the following videos to increase your understanding about the basic of analytical chemistry. There are several terms are regularly used in the analytical chemistry. First, analysis. Analysis is the process of doing experiments. It can be involve separation, identification, and determination of analyte in the sample. Sample, it is to obtain the information about the population. What is analyte? Analyte is a substance of interest or chemical constituent to be separated, identified, and determined in the sample using a particular analysis technique. Normally, the analysis in analytical chemistry will involve separation. It is to separate the analyte from the sample or from the matrix or the interference. It can be done by using two types of analysis. First is qualitative analysis, meaning that qualitative is to identify the type of analyte present in the sample. Quantitative analysis is to quantify the amount or how much the analyte presents in the sample. This is the common example of analysis in analytical chemistry. This is the example of the process in the petroleum industry. In the petroleum industry, the collected crude oil will be further processed by using separation technique to produce a ranging of valuable products such as lubrication oil, fuel, diesel, kerosene, gasoline or petrol, even natural gas. So the type of the product is mentioned just now. It can be determined using qualitative analysis. And the amount of each product will be determined using quantitative analysis. Okay, the process in the analytical chemistry can be divided into two categories. Uh, First is classical analysis. It using qualitative technique. Second, instrumental analysis. It using quantitative technique. The classical analysis or qualitative techniques, it can be further divided into three, which are volumetric analysis, gravimetric analysis, and also the conventional separation technique. These three type of classical analysis will be covered in this subject of CHM 41. However, the instrumental analysis or the quantitative technique, it will be teaching in another advanced subject. We call it instrumentation. There are many types of instrument is listed here. Okay. For your information, all these instruments are normally very expensive. So we call it this instrument is high-end high-end instrument. As I told you, the high-end instruments are very expensive. Okay. Slightly detail on the classical analysis or qualitative, it depending on the chemical reaction. This why we will using volumetric analysis, gravimetric analysis, and also some basic chromatography techniques. This classical analysis will use only simple equipment or apparatus that are easily available in the laboratory, such as biorate, pipette, filter paper, analytical balance, Bunsen burner, oven, furnace, and many others. If you realize all these equipments are not expensive. They are relatively cheaper. So the classical analysis not use high-end instruments like the instrumental analysis just now. Okay, this is you. I think you are familiar with this. This is a periodic table. Periodic table can be presented in many ways. Some periodic tables are very simple, like this. Some periodic tables supplied a lot of information. This form of periodic table will be given to you during the quiz or test or even during the final exam. So as a student, at least you have to and know how to read the periodic table. So at least you know the symbol of the element, you know the meaning of relative atomic mass, you know the meaning of atomic number. Because you have to remember in analytical chemistry, we deal a lot of analysis of sample. Any sample, it can be composed of ranging composition of different elements that listed in this periodic table. So you need this periodic table to help you to do the calculation related to the analytical chemistry. For example, you have to calculate the number of moles, the gram of samples, the concentration of solution, and etc. So if you are given a sample, for example, sodium chloride, so from the periodic table, you know where to search sodium chloride. Uh, Sodium chloride. This is the example. At least you know sodium. For example, sodium chloride, sample containing of sodium chloride. So you have to do the some calculation related to sodium chloride. So you should know where is the location of sodium in A. So as you can see in this periodic table, sodium is here. It has atomic mass of 22.99. And also you should know where the location of chloride. So this is the chloride. It has the atomic mass of 35.46. So you should be familiar with the symbol of the element and also the atomic mass. Okay, as I mentioned just now, this is a few things that you should familiar with related to the periodic table. Uh, you know the name of elements, you know the symbol of element, you can differentiate what is the atom, what is the molecule, what is the compound, how to obtain or how to calculate the atomic and molecular weight, and also the molar mass and formula weight. Because all this information we need it when you need to write the empirical formula or chemical formula. These two formulas are normally we are using in the chemical equation and stoichiometric equation. Okay, moving forward to the SI units. Of course, there are several physical quantity in the field of science. However, for this subject, CHM421, analytical chemistry, I want you to understand two important physical quantities, which are mass and also amount of substance. So the unit for the mass, kilogram, symbol kg, whereas the unit for the amount of substance is mole, unit of mol. Okay, this is also another important table that you will use a lot in the calculation related to analytical chemistry. So these tables is discussed about the SI prefix. So a prefix is used in the SI unit to indicate a power of 10. So, for example, the number of mole can be written like this: 2 times the power minus 3 mole. So this number also can be written as 2 millimole, or even can be further simplified into 2 millimole. If you realize 10 to the power minus 3 is milli. The milli, the prefix of milli, the symbol is M. This why I want you to familiar with the prefix. For example, kilo is the power of 3, mega the power of 6, giga is power of 9, and also the tera is the power of 12. Oppositely, DC is -1, centi is -2, milli is -3, micro is -6, nano is -9, pico -12, and femto -15. Other than multiplier that you have to remember, you also have to remember the symbol. Okay, so at least for CHM 41 analytical chemistry, you have to remember several prefix. For example, you have to remember mega. You have to remember kilo, maybe deci or centi. This is very important. Milli and micro and also nano. So these are a few of prefix that you have to remember the multiplier and also the symbol because it frequently used during the calculation related to analytical chemistry. Okay. Uh, all right. This slide is talking about solute, solvent, and solution. Because analytical chemistry is dealing with the sample analysis, it sometimes the sample analysis can be in the solution form. Okay, what is solute? Solute is a substance that dissolves in a solvent. Its amount normally lesser than the amount of solvent. It can be solid, liquid, or gas. Okay, what is solvent? Solvent is a substance that can be used to dissolve another substance, normally in the form of liquid. So, solution. Solution is the results of dissolving solute in solvent. Meaning that if we have a specific amount of solute dissolved in particular volume of solvent, it can produce solution uh, of uh, of a specific concentration. So you can say in any solution, it containing of solute and also it containing of solvent. Okay, so as I said just now, the produced solution has specific concentration. So what is concentration? Concentration is the amount of solute in a given volume of solution. The concentration of solution can be ranging. Some solution can be concentrated and some also can be diluted. So the concentrated solution, it appeared dark in color. It has a large amount of solute and small amount of solvent. Diluted solution, it appeared light in color. It has a small amount of solute and a large amount of solvent. So if we have different volumetric conical class, volumetric class. If you have different volumetric class containing a solution of different concentration. So the color intensity of the solution, it will be indicate the degree of concentration. For example, if we have a solution with dark in color, meaning that it show the solution is highly concentrated. It's compared to another vial have a solution with light in color. It has the diluted solution. Uh, Another presentation in a beaker. This the solution in this beaker, the solution A in this beaker, we can say it's low concentration because it only has a small amount of solute in large volume of solvent. Is compared to the solution C, the concentration of this solution is higher because it has a larger amount of solute in the solution. Okay, so quantities versus concentration. Is discussed a lot in the analytical chemistry. It's dealing with sampling or dealing with the sample. The sample will have analyte or a substance of interest. So we have to be able to identify the quantity of analyte or even the concentration of the analyte or concentration of the sample. There are various ways to express the amount of solute in the solution that can result different concentration. So so we have to learn the units that normally used in quantity and also the unit used for the concentration. For the quantity, its unit normally written is a mole or sometimes can be written is millimole. For the concentration, it can be expressed in many ways. Sometimes we can express as molarity, sometimes can be normality, percentage concentration, weight per volume or volume per volume, or also in the PPT, part per thousand, ppm part per million, and also ppb is part per billion. So I think this all for this video. See you again on next time. Okay. Thank you very much and bye bye.